If you place three dots at random on a grid and draw lines between them, it always forms a triangle. You can easily find the area of a triangle, and if you do this many times, you can take an average. So what is the area of an average triangle? Sounds like an easy question. But in the last video, I showed that a lot of people on the internet don't know what it is. It's very hard to calculate. And I showed how we use maths to calculate the area of a square. So in this video, we're going to move on to the triangle. It's complicated maths and I won't show my face. So if you want to see the last video, check that. Otherwise, the important difference here is the ordering. So we can name our three dots A, B, C from left to right. There's 6 potential orderings for the Y, and we have to find all those potential areas and then average across them. We do this by drawing a rectangle around the triangle and subtracting the area of the triangles inside from the triangles on the outside of the rectangle. Now, you might notice there's basically 2 kinds of triangles that we need to deal with. So what we do is we cut it down and we deal with those 2 and then we average across them. So now I'm going to get into some more complicated maths on that. So we now see where we calculate the area. The whole box here is the big area of CY minus BY multiply CX minus AX. So the whole box is this term here. This term, CY minus BY, CY minus BY, CX minus BX, it's this triangle in here. And this term, AY minus BY, BX minus AX, it's this triangle out here. CY minus AY, CY, CX minus AX, CY minus AY, CX minus AX is this one. So those are the 3 triangles. And the square, so that is the equation. If we multiply all of that out, we get this. This is a big mess and we have to integrate across all 6 variables. But there's no reason why we shouldn't, as long as we follow the rule. So first of all, we start with AX in this integral, and AX, we have to fill in these integrals very carefully here. What size? So AX, the A on the X coordinate has to be from 0 to B. It can be anywhere in that gap. The BX, once we know there's an A, the BX can be anywhere from 0 to C, and then once we've taken care of the BX, the CX can be anywhere from 0 to 1. However, when we go the other way, so to start with the BY will go from 0 up to AY. AY will go from 0 up to CY, and CY will go from 0 to 1. Unfortunately, with triangle 2, triangle 1, we've named it, but we run into an issue here. These look different, and you can see the big box is the same. CY minus AY, CX minus AX. But these other areas are different. So this is correct for this one. BY minus AY, CX minus AX is the blue area marked here, and CX minus BX, CY minus AY is the red area, and this is the big green area, CX minus AX, CY minus AY is obviously just going to be half of the box. However, if we go over to this side, these are different. This is actually BX minus AX and CY minus AY. It's a different set of equations. So we cannot use this. We have to integrate separately. That means we will have a different set of equations on this side of the line to that side of the line for the point B here. Now that means that as before, we can multiply out and set the limits. However, integrating ax is simple as before between 0 and bx. When we integrate bx, the second of these two integrals, we need to know what it is between, and it must be between this point here and cx. And we would have to have an equation for this point. That is not obvious at all how we get that, and you can't put the limits into that equation without some way of knowing it, or some transform or something to say whether it's going to be this triangle or that triangle. And without that, it's going to come back to 0 because everything will cancel out. You've got to know which side of the line you're on, or it just won't make sense. So that is the problem, and that is why we can't integrate and find the area of the average triangle this way. So is there another way? Well, this channel is all about challenges, and can you find this? There's not really a great answer out there on the internet, but in the next video I'll give the best answer that I have found. Maybe you can find a better answer. All the ones I've seen are either too complicated or slightly flawed, so I've created my own. In the next video I'll show that, but here's the solution from randomly generating them. If you want to try and find it, this is the target you're looking for.